Hi again. I hope you are all good. And we are looking at expressions, algebra. In algebra today, we are looking at algebraic expressions. I don't know who's watching, but if you are, please keep this to yourself. The agenda for today is vocabulary and definitions in terms of algebra, in terms of algebraic expressions. Simplifying algebraic expressions, expanding brackets. Let us begin. Would you be able to solve this? That is x to the power of 6 plus a squared x cubed y, all divided by x to the power of 6 minus a to the 4 y squared, or y to the 2. Can you try? Let us look, while you are pondering on that, on the previous question, let us look into algebraic expression. Let us explain what is an algebraic expression in that matter. A mathematical expression consists of variables, numbers, and operations. That is a mathematical expression. It consists of variables, numbers, and operations. Let us look directly, what are we talking about? Variables are your unknowns, such as your x and your y. At times it can be p and q, times it can be r and z. The variables here is a symbol for a number we don't know. It's an unknown. It's usually x or y most of the time. So yes, a variable is a symbol for a number that we don't know. So it's an unknown. That is a variable. Other than a variable, we've got something very nice we call a coefficient. A coefficient, by definition, is an integer used to multiply a variable. A number in front of a variable, or an integer used to multiply a variable, is known as a coefficient. Generally, and most famously, we would just say a number next to a variable. That is a coefficient. And other than that, you have your exponents, or we can call them powers, or you can call them indices. Exponents of a number says how many times to use the number in a multiplication. It is written as a small number to the right and above the base number. It's called an exponent, it's called a power, it's called an index. Depends on the country that you are in. In South Africa, it's called an exponent. In Vietnam, it's known as an indice. And then in other countries, they call it a power. But we also call it a power in South Africa. And there is a constant. Finally, we've got a constant. A constant is a number on its own, or sometimes a letter such as A, B, or C to stand for a fixed number. That is a constant. It's a real number. Let me put it that way. A constant is just a real number. Constant is a real number. So, other than that, you have what we call terms. Now, this has been an issue with most learners and most students across, that I've taught before. A term is a combination of coefficients and variables. For example, 2xy, where the x and the y make up a term. But let me explain how terms separated, because another person can say x is a term and the y is a term. No, be careful. In this particular example that I've highlighted to you right now, your terms are separated always by either a positive or a negative. Either a positive or a negative or a positive. So this is a term. So because it's separated by either a negative or a positive. So how many terms do we have? Firstly, we have the first term. Then there's a negative, minus. Then there's a second term, minus. Third term, plus. There's a fourth term. So how do you find a term? Please listen to this carefully. Whenever there is a plus or a minus, whenever there is a positive or negative in front of a number, of the next number, then we call those terms. So you need to really be careful around the definition of a term, on what is a term. Let's simplify algebraic expressions. Investigate the results when you substitute various values, positive or negative, for x in both of these expressions. I mean, you can say x is 2. Substitute x here and see what will happen. I would want you to do that. What is your conclusion? Which expression would you rather use in this particular two? I mean, I think you know the answer. If you look at the first expressions, that is the x plus y. X plus 1, it's a little bit easier to work on, because if I substitute 2 here, I'll have 2 plus 1, that is just 3. But if I substitute 2 here, I am going to do lots of work, because I'm going to have 2 squared plus 6 times 2 plus 5, all divided by 2 plus 5. And that's just another lot of work that I have to do on my side. So which one would you use? I think we're going to have the same answer. I just think so. But we spoke of terms. Other than terms, we have things that we call like terms. What are we talking about? Like terms are terms that have same variables and powers. Like terms are terms that have same variables and powers. There are like terms for addition and subtraction. Can you simplify this algebraic expression by collecting like terms? Let's look into the algebraic expressions. 3x squared minus 2xy minus 6y plus 4xy minus x squared. Let us look for like terms. I want you to realize the following, that 3x squared is a like terms to minus 1x squared. That is minus x squared, because remember, it's minus 1x squared. If it's minus x squared, it's just minus 1x squared. So 3x squared minus x squared, they are like terms. Minus 2xy plus 4xy. So you have minus 2xy plus 4xy. Do you understand? That's how you get to like terms. 3x squared minus x squared. So what do terms have? They say have the same variables and powers. Immediately when you have same variables and powers, you must know that those things are like terms. And minus 6y doesn't have a like term. So you add or subtract those like terms. 3x squared minus x squared. 3 apples minus an apple. So 3x squared minus x squared. You have 2x squared. Minus 2xy plus 4xy is 2xy. And then finally, minus 6y will just be left with that particular minus 6y as it is, because there's no any like term you can join with that. And that's that. Let's look into these examples. What are you going to do here if you simplify by collecting like terms? Let's go. Start. What are you going to do? Fight for it. First one. There you go. 3gh and minus 2gh, 5jk and 7, they are not like terms, but you can see the purple ones are like terms. 3gh minus 2gh is just gh, and then you keep the other terms just like that. What are you going to do with the second one? Collect like terms. 3ba minus ab plus 3ab minus 5ab. Ladies and gentlemen, I must tell you that AB and BA means the same thing. It means the same thing. 3 times is like 3 times 2 and 2 times 3. It's the same thing. So BA is the same as 3BA. So I mean, if you can see all these are like terms, you can have them as 3AB minus AB plus 3AB minus 5AB. That's it. That is why 3ab minus ab, you are left with 2ab plus 3ab is 5ab minus 5ab is 0. That's why you're having that 0 there. And there you like terms for the next one. You've got 4ab minus AB, because BA is the same as AB, by the way. That should be 3AB, and then 10BC minus 7BC, because CB will be BC. That will be 3BC. So you have 3AB plus 3BC. Can you look into the next one? 5A cubed plus A cubed. So those are like terms. There we go. I hope you now understand how to add your like terms, and that is why you should be able to do this last one. Pause the video and do the last one. And you should have the following answer. You should be having the following answer. That is how you simplify by collecting like terms. Let's see what we do when we multiply. Can you simplify this algebraic expression by collecting like terms? There we go. When we multiply, you've got 6x squared y and 2y squared, y cubed, x to the 6. Here actually what you are doing, these are what we call them exponential expressions, because what you do whenever you multiply, you add your exponents. Whenever you multiply, it's law number one of exponents. You'll see further when I'm getting closer to exponents. So the 6 times 2, they are just real integers, real numbers. 6 times 2 is 12, x exponent 2 and x exponent 6. You keep the x and then you say 2 plus the 6, and the y exponent 1, because the y has always an exponent 1, and you are able to say multiply by y exponent 3, so you keep the y, you have the 3 plus 1, or the 1 plus 3. That's why you have 12 exponent 12x exponent 8, y exponent 4. We can also distribute bracket powers, but this is also the laws of exponents, where the 3 are all raised, all exponent 3. 3 are all exponent 3. So the 3 is raised to the 3 and the r is raised to the 3. Let me repeat what I've just said here. The 3 is raised to the 3, meaning 3 exponent 3, which will be 27, and then r exponent 3, which is just r exponent 3. So that is why you're having 27r cubed. That's why you're having 27r cubed. It is important. Simplify these as much as possible. This is your duty. Go for it. Okay, have some time. You can work on it. Are you able to do it? Pause the video and do it. You will then realize that after you've paused the video and able to do these particular sums, you would have gotten the following. You would have gotten the following answers. Let us also look into what we call distribution. What is distribution? Is when we simplify algebraic expressions with brackets. For example, simplify this. 2 into 3 plus x, 2 into 3 plus x. 2 into 3 plus x, what do? You multiply the 2 times 3, that's why 2 times 3. After that, you multiply the 2 times the x, which is positive. This positive comes back here, there it is. There it is, then the 2 times the x. We call this the FOIL method. Actually, no, it's not the other FOIL method, because we normally use the FOIL method when we use binomials. Be careful. So the 2 to the 3 multiplied by 3, then plus 2 multiplied by x. But 2 multiplied by 3 gives you 6, and plus 2 multiplied by x gives you 2x. And that's that. So you've been able to simplify that. So the diagram helps to show that, I mean, you can look into that diagram and understand why what we've just done is the truth. You can definitely do that. When expanding brackets, multiply each term inside the brackets with the term outside. What do we mean? It's just what we explained. What is it? What's this going to be? We're going to 7 times 4, and then we're going to come back and say 7 times minus a. 7 times 4, then we're going to come back and say 7 times minus a. So this is 7 times 4 minus this minus sign which was there in the bracket. 7 times minus, I mean 7 times 8. So the minus, we kept it. 7 times 4 is 28, and a minus 7 times a will be 7a. And that's it. This is simplified. Remove the brackets and simplify if possible. Can you go? Hey, he's dancing. Yay, 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 yay. There's your Father Christmas dancing there. Go for it. How are you going to do this? You multiply throughout the brackets. So make sure you do the same thing. The 0.4 multiplied by 2, then 0.4 multiplied by x, and then come back and says there's a minus 1 there. I must state that, you know, many learners tend to, if there's just a negative, it means there's a negative 1 here that you multiply through. Be careful about that, okay? Should be standard form that you know that there's always a negative 1 there. So you always say negative, that negative 1 will also be multiplying the x, and then you're going to come back and say that negative 1 multiplying the 3. So, and then you remember I said the 0.4 multiply the 2, and then the very same 0.4 multiplying the x. Okay. And then also you do the same with this one and the other one and the other one. Yay, 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 yay. Old man is dancing there. Old man is dancing there. You must go further and then realize that this is what you are going to have. Minus 4x, 1.4x minus 2.2. And that's what you're going to have at the end. These are going to be your answers after you've tried that.